Hello friends, and welcome back to our channel. Nuclear bombs are one of the most powerful weapons ever created, and understanding their impact can help us grasp the gravity of their use. In this video, we'll explore the science behind the explosion, the immediate effects on the environment and people, and the long-term consequences of such a devastating event. Stick around as we make this complex topic easy to understand and engaging. There are two main types of nuclear bombs: atomic bombs, A-bombs, and hydrogen bombs, H-bombs. A-bombs, like those dropped on Hiroshima and Nagasaki during World War II, work by fission and release energy equivalent to 15 to 20 kilotons of TNT. It releases energy similar to the sun's core, creating a massively destructive fireball. Hydrogen bombs, H-bombs, are even more powerful, as they use a combination of fission and fusion to release energy. This makes H-bombs exponentially more destructive than A-bombs. Being at ground zero of a nuclear explosion is fatal. For example, a 10-kiloton bomb, similar to those dropped on Hiroshima and Nagasaki, could instantly kill about 50% of people within a 2-mile radius, as reported by a 2007 Preventive Defense Project workshop. This destruction results from fires, intense radiation, and severe injuries. The blast's pressure, collapsing buildings, and flying debris would inflict most of the damage. Within 0.5 miles of the detonation, nearly all buildings would be destroyed or heavily damaged. How nuclear bomb works? Before we can understand nuclear bombs, we need to start with the basics of atoms. Atoms are made of protons, neutrons, and electrons. The nucleus, at the atom's center, contains protons, positively charged, and neutrons, no charge, while electrons, negatively charged, orbit around the nucleus. The number of protons equals the number of electrons, giving the atom a neutral overall charge. For instance, a carbon atom has 6 protons and 6 electrons, keeping it balanced. This atomic structure is key to understanding the reactions in nuclear explosions. Nuclear bombs release energy by manipulating the forces that hold an atom's nucleus together. There are two main processes to unleash this energy. Nuclear fission. It occurs when the nucleus of an atom is split into two smaller parts, releasing a lot of energy. This process is used in both nuclear reactors and bombs. When a neutron strikes a uranium-235 atom, its nucleus breaks apart into two smaller atoms and releases more neutrons. These neutrons can trigger further fission, creating a chain reaction. As the smaller atoms stabilize, they also emit gamma radiation. Essentially, the neutron starts the fission, causing the U-235 atom to split, which releases energy, extra neutrons, and gamma rays in the process. Nuclear fusion is what powers the sun. In fusion, two smaller atoms come together to form a larger atom, releasing even more energy than fission. Fusion is a cleaner energy source but harder to control. Both processes show the immense power stored within atoms, and scientists are still exploring their full potential. Fission bomb design. In a fission bomb, the fuel is kept in small, separate pieces called subcritical masses to prevent an accidental explosion. These pieces are too small on their own to cause a chain reaction. To create a nuclear explosion, free neutrons are needed to trigger the reaction. A neutron generator helps with this by using polonium and beryllium. When the bomb's core is compressed, these materials react, producing neutrons that start the chain reaction. To make the reaction more powerful, a tamper made of uranium-238 is added. This tamper reflects neutrons back into the core, making the explosion more efficient. In bombs using uranium, a gun method is used. Imagine two pieces of uranium, a bullet and a sphere. When the bomb is triggered, explosives push the bullet into the sphere, causing a chain reaction and a powerful explosion. The little boy bomb dropped on Hiroshima used this method. In another type of bomb, like the Fat Man dropped on Nagasaki, explosives compress the core to make it supercritical, leading to a large explosion. This method, known as implosion, was more complex to design but resulted in a massive explosion. Fusion bombs. Fission bombs, like those used in Hiroshima, were powerful but not very efficient. Scientists quickly wondered if fusion, the opposite process, could be better. Fusion happens when the nuclei of two atoms merge into one heavier atom. When hydrogen isotopes, deuterium and tritium, are heated to extremely high temperatures, they fuse together, releasing massive amounts of energy. Weapons that use this fusion process are called fusion bombs, thermonuclear bombs, or hydrogen bombs. Fusion bombs are more powerful and efficient than fission bombs, producing much greater explosive yields. Nuclear bomb delivery. Building a nuclear bomb is a complex task, but delivering it to its target and successfully detonating it is an even bigger challenge. In World War II, bombs were dropped from aircraft, as seen in the attacks on Japan. Today, while that method is still used, modern advancements have provided more ways to deliver nuclear weapons. Warheads have become smaller, and many countries now use ballistic and cruise missiles. Ballistic missiles are often launched from silos on land or from submarines. These missiles leave the Earth's atmosphere, travel great distances, and then re-enter the atmosphere to hit their targets. Cruise missiles, on the other hand, have shorter ranges but are harder to detect and intercept. They can be launched from aircraft, ground-based launchers, or naval ships. Each type of missile offers different advantages, but all present significant challenges when it comes to targeting and delivery. How to save from radioactive fallout. The US government's Ready.gov recommends that if you receive a warning, either through official alerts or seeing a flash from a nearby nuclear detonation, you should immediately move to a basement or the center of a large building. It's crucial to stay sheltered for at least 24 hours to avoid exposure to dangerous radioactive fallout. Nuclear power can provide clean, reliable energy that reduces our dependence on fossil fuels, cutting down harmful greenhouse gas emissions. Rather than focusing on destructive uses, let's use nuclear energy as a powerful tool for progress and environmental preservation. Thanks for watching this video. If you liked it, then please click on the like button, subscribe to our channel, and don't forget to provide your comments also.